everyone, in this video we're looking at another matrix CSEC past paper question. We're just looking at one in this video, which is May, June 2013, and we have three parts here in this question. So let's go ahead and let's look at this question here. So we are given matrix M, so let's make this a little bit bigger. So matrix M is 2, 1, 4, 3. So our matrix M is 2, 1, 4, 3, and part 1 is telling us to find the inverse of matrix M. So part 1, so firstly we need to find the determinant, right? Remember, so determinant of matrix M, product of the first diagonal, 2 by 3, take away the product of the second diagonal, 1 by 4, so that's 6, take away 4, so the determinant is 2. So the inverse of matrix M is 1 over the determinant, so that's 1 over 2 by the new matrix. So for the new matrix, switch the numbers in the first diagonal. 3 comes here, 2 comes here. The 1 and the 4 remains the same, just change the signs, right? And that's the inverse of matrix M. And then part 2, they said to show that matrix, the inverse of M times M is equal to I, which is the identity matrix, right? So we're going to do that, and let's do that right here, see if we have some space. So part 2, so matrix, the inverse by M, we get the identity matrix. So that will be the inverse is a half, 3 minus 4, 2, and multiply M, which is just 2, 1, 4, 3, right? And now remember, we just have to multiply, forget the half for now, and now we're going to multiply those two matrices, the two by 2 matrices here. Alright, so let's go ahead and let's do that. So we're going to leave the half outside. Row by column, we are pro at this. So 3 by 2 plus negative 1, that should be a negative 1 there. Right, so negative 1. So 3 by 2 plus negative 1 by 4. That's a 4. And then 3 by 1 plus negative 1 by 3. That's first row, first column, first row, second column. And then second row, first column, negative 2 plus 2 by 4. And then second row, second column, negative 4 by 1 plus 2 by 3. So let's just simplify now. We're going to get 6 plus minus 3 plus minus 3 here. Then at the bottom you get minus 8 plus 8. And then we're going to get minus 4 plus 6. Right? So far, so good. Let's just go down a little bit and get some space. And then we're going to get, alright, let's just find the pen. Right. So a half is equal to, remember, plus and a minus is a minus, right? So that's 6 minus 4, which is 2. And then plus and a minus again. 3 minus 3 is 0. Here we're going to get 0 as well. And here we're going to get 2. And then after half by, multiply a half by every number inside the matrix. A half by 2 is 1. A half by 0, 0. We're going to get 0 here again, and then we're going to get 1. And this is the identity matrix, and that's it, right? So now let's look at the next, which is a little bit long. So this is the last part of the question. It's 5 marks. It's a longish part. So let's go. We have two 2 by 2 matrices here. This is a 2 by 2 matrix and a 2 by 2 matrix here, and that's equal to this other 2 by 2 matrix here. Firstly, let's multiply these two matrices on the left side. So row by column, right? So we're going to get 2. Alright, 2 by R, so 2 by R plus 1 by T, that's first row, first column, then 2 by S plus 1 by U. And then second row, first column, 4 by R plus 3 by T, and then second row, second column, 4 by S plus 3 by u. And that is equal to 2, 4, 1 minus 1. Simplifying the left hand side, you're going to get 2r plus t, then 2s plus u, then we're going to get 4r plus 3t, and then 4s plus, let's just double check this here. This is supposed to be u here. Make the 3 by u, my bad. Right? So then 3u. And that is equal to 2, 1, 4, negative 1. Now we have a 2 by 2 matrix on the left side and a 2 by 2 matrix on the right side. Now we have to equate, meaning, or now they're both equal matrices because the left hand side is equal to the right hand side, right? So now we could say the first entry in the left matrix, 2r plus t, is equal to the first entry in the matrix on the right side, which is 2. Then we could say 2s plus u is equal to 1. Coming down now, we could say 4r plus 3t is equal to 4. And then lastly, 4s plus 3u is equal to negative 1. Now we have 4 equations, and that's a lot. You have 4 equations, and we have to solve for r, s, t, and u. So looking at the first 2 equations with r and t, so 2r plus t equals 2, then 4r plus 3t equals 4. That is 2 simultaneous equations. You're going to get 2, 1, because it's 1 before the t, 4, 3, that's all matrix, by, now the 2 unknowns here are r and t, right? So r, t, right? And that's equal to 2, 4. Same thing that we do like matrix multiplication, right? Sorry, solving for simultaneous equations, right? So RT is equal to the inverse. So as I was saying, RT is equal to the inverse of that matrix 1, 4, 3 by 2, 4. I'm going to do the inverse and everything here, right? Just to maximize one space. Alright, so remember the inverse is 1 over the determinant. So determinant is 2 by 3, that's 6. Take away 1 by 4, right? Which is 4. And then we're going to switch the matrix. So we're going to get 3 here, 2 here, negative 1, negative 4. Multiplied by 2, 4. Now actually, if I look 2, 1, yes, this is the same matrix from the top, right? Right? And you see right here? So you could just use the information from there. You didn't have to do it over, right? But I just did it over because I wasn't seeing everything right away. But just something you should note, right? So RT is equal to 1/2 by 3, negative 1, negative 4, 2 times 2, 4, right? So now we're going down just to simplify and solve. So we're going to get RT is equal to, multiplying these two now. Now it's row by the 1 column. So 3 by 2 plus negative 1 by 4. Then negative 4 by 2 plus 2 by 4, sorry. Right? Let's just simplify that right in the corner here. So you're going to get 6 plus minus 4. And then minus 8 plus 8. So we're going to get 1/2 by, remember plus and a minus, so 6 minus 4 is 2, and then we're going to get 0 here, right? So RT, by 2 is 1, and then more by 0. So therefore, R is 1, and T is 0. Again, as I said, it's a long question, right? And now we're just doing the same thing now for the second pair of equations, right? So let's go ahead and do that one, get some space and do that one. Alright, now the last part, same thing again, pull out your matrix. 2, 1, 4, 3 by, again, the 2 unknowns are S and U here, right? SU, and that's negative 1, right? So now SU is equal to the inverse of 2, 1, 4, 3 by 1, negative 1. And I'm just going back again to the top. So 2, 1, 4, 3 is the matrix. So you see how that 2, 1, 4, 3, they asked us to find the inverse in part 1. So instead of keep on finding the inverse, like you see, we found it in part 1 already. So in this last part for R and T, I didn't need to go ahead and do all of that again. I could have just write it in, right? Using from the information from when I found it originally. So that's what I'm going to do here. So SU, right? It'll be a half 3, negative 1, negative 4, 2 times 1, negative 1. So SU is equal to, leave the half outside. And now we're going to multiply those two, plus negative 1 by negative 1. And then negative 4 by 1 plus 2 by negative 1. And let's just simplify. So you're going to get a half. 3 by 1 is 3, plus negative 1 by negative 1 is positive 1, so just 1. And then negative 4 by 1 is negative 4, plus negative. So we're going to get I should have to half by 4, and this is negative 4 minus 2, so that'll be minus 6, right? So a half by 4 is 2, and a half by negative 6 is negative 3. So my value for S is equal to 2. My value for U is equal to negative 3, right? And there we found the answer for R, T, S and U, right? Again, I know it's very long. You could pause when you need to, try, work out anything you need to, and all those things. It's a very long question. Well, sorry, the total here was wrong. Because the total took into consideration part A, right? But the total for the matrix part in this question was the 9 marks, right? So there's a lot of work in for 9 marks. I know you're probably thinking that, but when you actually know the method and it's so easy to do, it's the marks, it doesn't seem like a lot, right? I know looking at it initially, like, gosh, so much working for just 9 marks, but I mean, matrices, it's an easy topic. Again, it's just all about practice. But to me, I honestly said at the beginning, it's one of the easier topics, right? Just need to remember, practice, and so on, you will get it right.